Hi, I'm Nipayi Jasmine. We are Group 2, and this is the final presentation of our IoT application on Smart Car Parking System. Let's have a quick introduction of our presentation. First, we will talk about the functional specification of our system and also introduce the objectives of this project. Then, we'll move to the architecture part, which having the architecture and the technical background for the hardware and also the software architecture. Finally, we will have a conclusion of this project and then the suggested improvements for the future implementation. We decided to develop a system which could detect the vacant parking spaces and indicated it with the LED. We would like to output the information of the car park after calculating the remaining empty slots for the drivers. The system will also record the parking data of different parking slots. We have 7 objectives for develop this system. The system features and the architecture of both hardware and software are designed before the implementation. We should study the components to perform the proper installation. Testing our implementation should include to make sure our system can run successfully and verify the system that reach the expectations. And then we should also analyze the difficulties of our system by some case testing. I'm going to introduce the hardware architecture. As we are having the simulation on Tinkercad, some of the components are cancelled since the limitation on Tinkercad, including the camera, LoRa module, and the Wi-Fi module. So we would like to contain the following components for the hardware simulation, including the Arduino Uno R3, LCD panel, ultrasonic distance sensor, red LED, potentiometer, resistor, breadboard, and the micro servo motor. So this is the connection of the components of our hardware simulation. All the electronic components are connected to the Arduino microprocessor. We have assigned 6 digital pins from Arduino to the LCD panel, which contains 4 digital pins of LED DB4 to DB7 to the Arduino digital pin D2 to D5. The enable pins are connected to the digital pins D11, which toggles the data acknowledgements, and the RS pin is connected to the digital pins D12 for the register selection. Red or white pin is connected to the ground for toggling the mode to writing data to LCD. VE pin is connected to the potentiometer for adjusting the LCD contrast. For ultrasonic distance sensor, you only need 1 signal pin to sending data to Arduino. The 2 sensors are assigned to the digital pin D7 and D8. 2 LED are connected to D6 and D13 digital pin, also connected with the 220 ohms resistor. For the micro servo motor connection, it is connected to the digital pin D9 for receiving the signal from Arduino to perform its operation.
Hello, I'm Sophia. Now I will talk about 5 key considerations of building the circuits on Tinkercad. Firstly, we need to ensure the LCD panel can have a stabilized display so that it will not keep on blinking and make the drivers feeling uncomfortable when they are watching the LCD panel. Therefore, we set a delay time in each function in our code, so that it can have enough time to run each lines of code, and the LCD panel will not being unstabilized. Secondly, we need to ensure the LCD panel can have enough brightness so that the driver can see the display in a more clearer way. And to achieve this, we add a potentiometer in the circuit. This potentiometer on the right is used to control the brightness of the LCD panel. And for the third considerations, we need to ensure the ultrasonic distance sensor can detect the objects in real time. In the code, we declare two functions for the sensors to detect the objects. On the left part, function called check slot, it generates a pulse so that this function can keep detecting the distance of the object. And in the function on the right, we set that if an object is within 2 cm to 300 cm, it means that there is a car occupying the parking slots. And for the fourth considerations, we need to ensure that the red LED will be lights up when a car is occupied parking slots. And after the lights being lightened up, the LCD panel should update the number of available parking slots. And for the fifth key consideration, we would like to set the LCD panel to update the number of parking slots based on the detection of the two ultrasonic distance sensors instead of updating the information based on the database. The testing on Tinkercad, we will discuss more about the testing cases in our demo video. And for a summary of building the hardware part, we use ultrasonic distance sensor to detect the object, and the red LED will be lightened up when a slot is occupied. And there is a microservo for gate control. We didn't use IP camera and IR sensors in our circuits because there isn't any options for us to add in our circuits on Tinkercad. And in the Tinkercad, while using the Tinkercad, there isn't any communication modules for us to add. So that we will demonstrate the hardware part and the software part separately in the demo video. Let me pass the time to Tommy.
So above the software architecture, it is divided into three parts. One is the hardware, and then the server, and then the last is the database. Simply, the server will receive the data from the gateway, the hardware part, which contain the sensors information, and then the server will handle the data and then transform into some useful information and then store into the database. But sadly, the system cannot really communicate with the hardware in this stage. So basically, the server contains this kind of roles for the web page to access the function. Take an example. If the web page want to get some data about the car park status for now, so he can access this URL, so he can get the data from the server. Here is not many routines for the web page to use because it is not much that function the server can be used. So about the database schema, I take one of the example from the database. So this is the schema about the snapshot, which implies the status of the car park currently. So in this schema, the snapshot will contain vacancy, which is the number of the slot, and then some census data, which is a rate of objects containing many sensors information. And then the last one is created, which is the date, or you may say the timestamp for the snapshot created. So basically, the flow of the system is very simple. Each event are individually. If you trigger the event, and then he will do something. For example, if there are vehicle come in the park, and then he will trigger the event vehicle in, and then he will try to get the input card ID, and then use that card ID to create a new record and modify the database. So about the software system testing, basically we have tested about 6 tasks. From the most simple one, get the car park status from the API. If we input and request, or you may say just simply access that URL, and then we will have an JSON data for the output, so it can be used, and so it pass. There are much more things to say, but I just simply skipped it to the create new vehicle record because it is quite important for the testing. If we can insert the vehicle record, so we can start to calculate the fee of that vehicle. So luckily we can pass this test, so we can really calculate the fee for that vehicle, so it can automate the process. for the parking system. So there are some conclusion and suggestion about the system. So about the hardware part, the system when the system start, it should be detect the unavailable sort and display message, and then it should not affect the database. So about the software part, it is recommended to make improvement on data visualization. So when the data comes in, so we can present the car park usage rate in a line chart instead of some tests. And another improvement on the user interface is that we should imply some filter function or sort function for the table, so user can easily read the data from ascending or descending orders.